Hello and welcome to a lesson on solving multi-step linear equations. So we saw previously we were solving one-step equations. We're going to take those same skills and expand. Now we're going to solve equations that have multiple steps in the same equation in order to get to the solution. The essential question says, how do I solve multi-step linear equations? Did you know that the cost of a speeding ticket in some states can be calculated using an equation? They can charge you based off how much over the speed limit and then court fees and other stuff. So let's say it's $5 for each mile per hour over the speed limit you're going. So if you're going over by 15 miles per hour over the speed limit, you would take 5 times by that 15, and then they usually tack on court fees and emergency vehicle fees and all that kind of other stuff. So we're going to add on just a fee of $100. So your ticket that originally would have been 75, 5 times by the 15 miles per hour over the speed limit, that 5 times 15 would be $75. Tack on your court fees, and now you've got a ticket of about $175. So that's kind of an example of how it's used in some states. But little two-step equations or multi-step equations are used quite a bit in everyday math. We have two vocabulary words here today. We have distributive property, and we have like terms. Distributive property, this definition doesn't do too much. An example will make more sense, but it says when you multiply the outside number by all the terms on the inside of parentheses. What that's trying to say is if you have a problem like 3 times by x plus 5. If I have this, if I take this outside number, the 3 here, and I'm going to multiply this by both the numbers on the inside. A lot of times you'll see people draw, I call them drawing rainbows. You draw your rainbows and multiply. 3 times the x is 3x. 3 times by the 5, 3 times 5 is a positive 15. That's your distributive property. Okay, its main usage is to get rid of parentheses. And so when you get rid of those parentheses, then you can start doing other things like combining like terms, which is actually our next vocabulary word. Like terms. They are two terms, two pieces of an equation, with the exact same variables. In my previous example, I have two terms. I have a 3x, and I have a positive 15. Those two things cannot be combined together because they are not alike. They don't have the same variable. This has an x, this does not. Like terms would be something like 2m and a 3m. I can combine those together to get 5m. If I had negative 3 plus 6m minus 9, I could combine the negative 3 and the negative 9. Those are like terms. The 6m is not. Those would combine to give me a negative 12. Negative 3 minus 9 is negative 12. And the 6m would just come along for the ride. Okay, so that's some examples of how you combine like terms and what it means if two terms are alike. They have to have the exact same variables. So there are 5 steps to solving an equation. Most equations will follow these steps. There's always some exceptions. And this is kind of like a checklist, kind of like order of operations. When you're doing the order of operations, you always get rid of parentheses first if you have them, and then you do your exponents. Then you do multiplication and division from left to right. Then you do addition and subtraction from left to right. Well, when you're solving an equation, there's also this checklist. So the first thing on the checklist is we want to get rid of parentheses. Get rid of parentheses. And the way we do that is by distributing. By distributing. So we're going to get rid of our parentheses first by distributing. After we've distributed and we get rid of our parentheses, our second step is going to be to combine like terms. Combine like terms on each side of the equal sign. On each side. Now, these first two steps kind of go together. They fit a theme. Basically, those first two steps are to simplify the problem as much as you can. It's part of solving an equation, but we make the equation as simple as we can first. Then, the second half of these steps is where we actually start getting the variable by itself. Step 3, we're going to skip for today. This step 3 is kind of the whole point of the next lesson. It is going to be what you do if you have variables on both sides of the equal sign. But for now, we're going to skip it. Step 4, we get rid of addition and subtraction, just like we did in the previous lesson by doing the opposite. So if the variable is being added by 5, we subtract 5 on both sides. Our final step is get rid of multiply and divide. So we're going to get rid of multiply and divide last. So it really comes down to our first piece up here, the first two steps. We are going to simplify the problem. Make the problem simpler if we can. Then we get the variable by itself. Isolate the variable, you'll hear it called. The first few problems we're going to talk about are going to be on those first two steps. We're going to practice simplifying a little bit. So, simplify each expression. So you'll see there's quite a few problems here that have, well, they all have parentheses, and a bunch of them have like terms. So let's look at the first problem together, letter A. I'm going to take this, and I'm going to distribute this 3. It's really just a multiplication because there's only one term on the inside. So I'm going to do this multiplication. The point of it is to cancel out, or to get rid of the parentheses. So this will become a 6x. When I multiply here, 3 times 5, that's how I'm going to get rid of these parentheses. I'm going to get a 15. Now, my 6x and my minus 15 are not like terms. They don't have the same variable. I have an x here. I have no variable here. They are not like terms, so we cannot combine anymore. This problem's done. There's nothing else to simplify. Letter B. So, first step, get rid of our parentheses by distributing. I can distribute this outside 3 through. This is a 3 times by, there's a little multiply here, a little invisible dot, 3 times by the stuff in the parentheses. So I'm going to take the 3 times by the 2a and the 3 times by this minus 6. 3 times by 2a is 6a. That's 3 times 2 is 6, and you bring the variable along. 3 times by the minus 6 is a minus 18. And I just brought down my 4a plus. So I did this math in my first step. I'm simplifying. My second step of simplifying is to combine like terms. I'm looking to see, are there anything with the same exact variables I can combine together? And there are. This 4a and this 6a can be combined together. They are both positive. So 4a plus 6a is 10a. My negative 18 does not have anybody, so he just comes along for the ride. There is my completely simplified expression. 10a minus 18. All right, so you can see now all the problems there. So we did the first two together. I would like you to pause the video and try the next two on your own. You'll see I have letter D labeled as a challenge. There's a little trick in there. See if you can do them both. When you're ready, continue, hit play, and we'll go through both of those together. All right, letter C. Let's change color here, make it a little bit more visible what I'm doing. So I'm going to multiply the 2 times by the 3. That's how I'm going to get rid of those parentheses. That gives me 6. I'm going to multiply the 4 times by the 5x. That's how I'm going to get rid of those parentheses. And that's going to give me 20x. And that 20x and 6 cannot be simplified. They cannot be combined because they don't have the same variable. X, 6, I'm done. Letter D. Most people get the first half for this problem right. By that, I mean the left-hand side. You multiply the 3 times the h. You multiply the 3 times the negative 5. You got 3h minus 15. And here's where the mistakes start to happen. It's in this second set of parentheses. So you might be thinking, well, what the heck do I multiply here? I mean, a lot of students will just go, okay, minus 2 plus h, and just kind of drop the parentheses that are around here. Well, these parentheses are actually needed. Because of this minus sign here, this really becomes a negative 1 times by that stuff. So I'm going to multiply a negative 1 through. See, negative 1. There's a ghost 1, and that's the trick here. That's the challenge. That's what makes this hard, that nearly everybody gets it wrong their first time around. And when I do that, I'm going to get some slightly different answers. So the first piece here, the negative 1 times 2, is just negative 2. You probably had that on your paper, but for the wrong reasons. The negative 1 times h, though, that's where most of the mistakes happen, because you didn't multiply that by that before. So now I have this, and I can simplify. I have some like terms, a 3h and a minus h. I can bring those together. And that is just 3h minus 1h. There is only 1 here. If you ever have a variable without a number in front, it means there's 1. So 3 minus 1 is 2h. My constants, the guys without variables, I have a negative 15 and a negative 2. Those can be combined together. Negative 15 and negative 2 combined together gives us a negative 17. Now, on your calculator, you can do it like this. Negative 15 minus 2. So it looks kind of like this. Negative 17. You could do negative 15 combined with plus a negative 2. That's also negative 17. The only thing you really can't do on your calculator, it's gonna give you an error. So it won't even let me do it. If you try to hit like minus 15 minus 2, it doesn't like that. It doesn't know what you're minusing. So that's going to give me a weird answer. Okay, so negative 15 combined with a negative 2 is negative 17. And that can't be simplified anymore because this h does not combine with that constant. There's no variable there. So they do not have the same variable. So those are all 4 of those combining like terms, simplifying. So now let's actually start to solve an equation. So our second skill in this lesson is solving some equations. And we're going to use those steps from the previous page to go through. So as I'm going through this, in my head, I'm going through each of those steps, my checklist. So step 1, get rid of parentheses. Well, I don't have any parentheses in this first problem. There are none. Step 2, combine like terms on each side. There's nothing to combine here. I can't combine the 6m and the 11. On the other side, the 83 is by himself. There's nothing to combine there. The next step we have is get rid of additions and subtractions. So my variable, the m here, is being multiplied by 6 times by 6, and it's being added by 11. Well, I'm going to get rid of the addition and subtraction piece first. The reason why we do this is to avoid having ugly fractions in our problem. We could actually do this the other way, and maybe I'll show you that in a second. But it makes the problem uglier. This is the method that will give you the easiest results most of the time. So I did subtract by 11 while I was talking. 83 minus 11 is 72. And now to get rid of this multiply by 6, just like we did in the previous lesson, we're going to divide by 6 on both sides. These cancel out, and m equals, should be 12. 72 divided by 6 equals 12. And that is our solution. The directions say be sure to check your answer. We can do that because we learned how to do that in the previous lesson. I'm going to take this 12 and I'm going to plug it in for the variable in the original problem. 6m plus 11 equals 83. If I plug in a 12 here, the math should work out. Well, let's see. 6 plus 11 equals 83. So 6 times 12, I'm doing order of operations now on the left-hand side of the equation. 6 times 12 is 72. 72 plus 11 is 83. And that math checks out. So I've done the work, I solved the equation, and I checked my solution. M equals 12. Letter B. So to solve this equation, let's see. Can I do any simplifying? Well, actually I can. On the right-hand side here, I have a 7 times 2. That seems a little useless to have that. I mean, we can do 7 times 2. That's just 14. So let's simplify the problem a little bit. There. That looks simpler already. Now we solve. So I've gotten rid of all my parentheses. Combine. Can I combine anything here? No. This 3 is attached to the b. You cannot combine, you can't do 3 minus 13. So there's nothing to combine on the left. There's nothing to combine on the right. So now we start getting the variable by itself. We're going to get rid of this minus 13, the addition or subtraction, by doing a plus 13 on both sides. We have b over 3 equals 14 plus 13 is 27. And now in order to get rid of that divide by 3, we are going to multiply by 3 on both sides. And b equals, I believe it's 81, but I always like to check my math. There we go. 81. B is 81. And if for me to check this, I can check this using my calculator as well. I'm going to plug in 81 right here. So I'm going to do 81 over 3 minus 13. So you see I've kind of typed this whole equation into my calculator, replacing the b with 81. If I hit enter, we should get, well, 14. It's not going to say 7 times 2. And look at that. I've checked my solution, and it works. Two more for me. So letter C here, let's see. I have parentheses. I am going to distribute. That gives me a 12k. That gives me a minus 16. And on the left-hand side, I just have a 20. Parentheses gone. Check. Combine like terms. There's nothing to combine. I can't combine a k and a no k. Those cannot be combined. Check. Next step. Get rid of the addition and subtractions. Get the variable by itself. So I'm going to get rid of this minus 16 by doing plus 16. This 12 is attached to the k. The 12 and the k would actually move together because they're combined using a multiplication. That's why we get rid of the addition and subtraction first. 12k equals 36. Now when I divide by 12 on both sides, I'm dividing to cancel out that multiply. I'm going to get k equals 3. And quick mental math. I'm going to check my solution. Or better, let's just type in the calculator. That way I can show you that I'm not cheating. Minus 4, close parentheses. All right, so I did 4 times by, with my parentheses, 3 times 4. I'm sorry, 3 times 3, because we found that k is 3 minus 4 equals 20. And that's what this is. So this side is equal to 20. This side is equal to 20. I've checked my solution. Letter D. I don't have any parentheses. I can't combine any like terms. There's nothing to combine on the left. There's nothing I can combine on the right. So I'm right into solving equation. I'm getting the variable by itself. I'm going to get rid of the adding and subtracting first, which would be this piece. This 1/9 is attached to the variable. They are one thing. They are one term. So I'm going to add 14 to both sides. 1/9 d equals 6. That is our negative 8 plus 14 is 6. And just like in the previous lesson, we learned how we can solve this equation, how to get rid of this 1/9. By hand, we would multiply both sides by the reciprocal of that fraction. If I multiply by 9 over 1, that makes this fraction cancel, because across the top, we'd have 9. 9 times 1 is 9. Across the bottom, we'd have 9. 1 times 9 is 9. And a 9 over 9 is just 1. That would be a 1d. And that's okay. That is what we're trying to get. We're trying to get the variable by itself. That ghost 1 doesn't change the problem, doesn't change the solution. When I multiply by the reciprocal on the other side, I'm going to make the 6 a fraction by putting it over 1. Now when I multiply across the top and I multiply across the bottom, I'm going to get 54 over 1. 9 times 6 is 54 over 1. And all in this part of my problem, all these little ghost ones can kind of go away. I don't really need them. So 54 is D. Solution. Now, if we are cheaters, from this same step, I'm going to go back to red from the problem here. We had 6 equals 1/9 d. If we were going to cheat and use our calculator, all we would need to do is, to get rid of this multiply by 1/9, is divide by 1/9 on both sides. And then we type in our calculator, 6 divided by 1 fraction 9 equals, and it spits out the same solution. So that is letters C and D. Here are 2 for you to try. Let me see if I can zoom in a little bit for you, if I can zoom. Okay, there's letters E and F. Please pause the video, try these 2 on your own. When you're ready to continue, hit play, and we'll go through it together. All right, so let's see how you did. You should have started, letter E, by subtracting 6 on both sides. That makes this cancel out, and we'd have 1/3 h equals 8. 14 minus 6 is 8. Then, no matter what method you use to get rid of that fraction, either you multiplied both sides by the reciprocal or you divided by -1/3, you should get h equals 24. I did this in my head, doing multiplying by the reciprocal. I know that, and if I multiply by 3/1 here and over 1 there, across the top I get 24, across the bottom I get 1. I simplify 24/1 in my head, and that's how I got it. So when you get good at this multiplying by the reciprocal thing, it actually is faster than typing it into the calculator. You have to know your times tables, but it is faster than just typing it in. Letter F. Let's see, there's no parentheses, there's no combining like terms. We would start by subtracting 2 on both sides to cancel out this plus 2. We now have 9r equals 36. In order to get rid of the multiply by 9, we're going to divide by 9 on both sides, and r equals 4. And I can then check all of these equations if I needed to. I'll check letter F here. So 9 times 4 plus 2. I typed in what I have here, replacing the variable with the solution I got. So 9 times 4 plus 2. When I hit equals, I should get 38. And look at that, I do. So I've now checked this solution, and I know it's right. Okay, 2 more. Go ahead and pause the video. Try these 2 on your own. When you're ready to continue, hit play, and we'll go through them both together. All right, so let's see. Letter G. So there's no parentheses, there's no combining like terms. So I'm going to start getting the variable by itself. I'm going to get rid of this minus 3. The 4 is attached to this w. It's technically a -4, but he's attached to the w through divide. But I can get rid of this other term. So I'm going to add 3 to both sides. 7 equals -w over 4. Now, I could get rid of this divide by 4. I could multiply by 4 on both sides. But that's not the best choice. This will cancel out the 4's, but I would still have a -w, which I don't really want. I'm going to have to do another step then to get rid of it. What I can do instead is, instead of multiplying by 4, I could multiply by a -4. Because a -4 time, or this -4 cancels out with this -4, and I would get just plain old, oopsie, w, without the negative in front. And that's kind of what we're looking for. We should get a solution of -28. Now, let's play pretend here for a second and say that you didn't do that. Let's say you just did times by 4. Let's see how this would play out. So you would still have a -w. This 4 and that 4 would cancel. On the left-hand side, when you do this 4 times 7, you will get a +28. And go, well, how the heck do I get rid of this -1? Well, it's a ghost 1. It's -1 times w. And that is just another multiplication. So we would get rid of by dividing by -1 on both sides. Now that -1 and the other -1 cancel. On the left-hand side, when you take 28, divide by -1, you do get -28 for a solution. Now, this does work, but it's an extra step. The better choice is, in the previous step up here, is recognizing, hey, I can cancel out the 4's, but I can also cancel out the negatives if I would have multiplied by a -4. Letter H. This is actually one of the first few problems we've had where you actually need to combine like terms first. So first off, there's no parentheses. There's none. But on both sides of my equal sign, there is stuff to combine together. I can combine those two. A 5g and a 3g can be combined together. On the left-hand side of the problem, I have 8 g's. On the right-hand side, 15 plus 9. I can combine 15 plus 9 and get 24. Combine like terms. After you combine like terms, now the next step is to solve the equation. I'm going to get rid of that multiplied by 8 by dividing by 8. That was a little ugly. Let's try it again. Divide by 8 on both sides. And I'm going to get g equals 3. I could check this solution. So if I take 5 times 3, because I'm plugging a 3 in for the g, plus 3 times 3, so 5 times 3 plus 3 times 3, when I hit equals, I should get 24, because this 15 plus 9 is 24. So I know my solution is correct. Zoom back out so you can see both of them. You can check your work. Two more. So the problems you might notice are getting a little bit more complicated. There's more stuff. And that's part of building your confidence and building your ability levels. We start out with smaller, simpler problems and we build harder. So if you could please pause the video, try these two. If you get stuck or if you need a little help, maybe pause the video until I catch up and then try more of the problem on your own. Or if you got it, complete both these problems and hit play at the end and we'll go through it together. All right, letter I. First steps, distribute. I got to get rid of those parentheses, so this becomes a 4 plus 8. 4 times 1 is 4. 4 times 2 is 8. On the left-hand side, I can combine these together in the same step. So let's see. -9 plus 3. I'm ignoring the r's. I'm doing the math for the numbers. -9 plus 3 is -6r. If we keep solving, -6r equals 12. I simplified 4 plus 8. 4 plus 8 is 12. I simplified. Now my last step is to get the variable by itself. Solve. This is a multiplication. -6 times r. So I'm going to divide by -6 on both sides. And r equals -2. Letter J. There's my equal sign. On the left-hand side, I have a lot of different stuff to do. Let's see. We'll start with parentheses. Draw your rainbows and multiply. That becomes 2m minus 16. And I'm bringing everything else along for the ride. Now, I see I have a 2m and a minus 3m that can be combined together. And so I'm going to. -3 plus 2. -3 plus 2. -3 plus 2 is -1. So I have -1m on the left-hand side of the equal sign. And I brought everything else down. Now I have here a two-step equation. This is very, very similar to the other equations we were solving at the beginning of this lesson. I'm going to get rid of the piece not attached to the variable first, the addition and subtraction. So I add 16 on both sides to cancel out a minus 16. I have negative 1m equals, that should be 40, but I'm going to double check just to make sure I'm not making a mistake in my head. Good. Now here we have this negative 1m. In order to get rid of this negative 1, this is negative 1 times m. That is a multiplication. So if I divide by negative 1 on both sides, these cancel. And m equals negative 40. And we have our solution. So hopefully you were successful on both of these problems. You'll see that we're kind of getting more and more steps. This letter J was distributing step 1, combining like terms step 2, get rid of add and subtract, get rid of multiply and divide. That was 4 steps long. And hopefully you're able to get from step to step. And if you got stuck anywhere, referring back to the steps at the beginning is helpful. And also just getting more practice is helpful. Okay, here's 2 more problems, one for me and one for you. I'm going to do letter K. I'm going to have you do letter L. I know, I get the easy one, you get the hard one. So let's see here. On the left-hand side, there's nothing to do. It's a 22. On the right-hand side, I can combine those together. I have a 5b minus a 7b. 5 minus 7 is negative 2b. Now, to solve the equation, I'm going to do the opposite of multiply. This is a multiplication. Multiply by negative 2, so I divide by negative 2 on both sides. And b is negative 11. One for me, one for you. Go ahead. Pause the video, try it, multiple steps, take your time, if you're getting stuck, refer back to the checklist at the beginning of the lesson, and when you're ready to continue, hit play, we'll go through it together. All right, step 1, distribute. Got to get rid of those parentheses. This gives us a 4g plus 4. I'm going to write down the rest of the problem. So negative 4 plus 2g equals 24. Now, I'm going to combine like terms on each side. So on the left-hand side, I see I've got a 4g and a 2g that can be combined together. 4g and 2g, they're both positive. That gives me 6 g's. I have a negative 4 and a positive 4. They can be combined together. Those are like terms because they don't have a variable. That makes them the same. So a negative 4 combined with a positive 4 is 0. Don't really need to write plus 0. I'll erase it in a second. And on the right-hand side, we have a 24. So this problem actually simplifies down to, my steps would give me just 6g equals 24. And then when I continue to solve, I'm going to divide by 6 on both sides, and g equals 4. That wasn't that bad. It looked ugly, but it wasn't that bad. All right, so now we're into the application stage of the lesson. This problem says Monica wants to have a funnel cake booth at a county fair. It costs $42 per day, plus a one-time registration fee of $150. How many days could Monica rent her funnel cake booth if she has $400 to spend? Well, so she has to pay $42 a day, every day. Plus she has this one-time registration fee, I'm just going to put reg fee, of $150. So if I combine this money together, we want to know how many days could she rent it if she only has $400 to spend. So what I've written here is it's something called a verbal model. Basically, it's an in-between step between the word problem and your equation. So I'm going to translate this into my final equation. So $42 a day means $42 times by the number of days, plus your registration fee of $150. And we're going to keep going until we've used up all $400. We got ourselves an equation. That's a two-step equation that we know how to solve. We did this earlier in the lesson. So let's see. We're going to start by getting rid of this plus 150 by subtracting 150 on both sides. Um, 400 minus 150 should be 250, but I'll double check. Yeah, it is. And I'm going to divide by 42 on both sides. And D equals 250 divided by 42 is 5.9523 stuff. Okay. Now, this answer doesn't quite make sense. Or it makes sense. We solved the equation. We got a number. We got a solution, but I don't know if she's allowed to rent it for 0.9523 whatever number of days. She doesn't have enough money for 6 days. So how many days could she actually rent her booth? Well, she can only rent it for 5. 5 days. Because she doesn't quite have enough money for 6. So this would be an example where having a decimal solution just doesn't quite make sense. If you're thinking about the problem, it doesn't quite work out. Letter B. A farmer has a field with 19 rows of pumpkins in it, and a small side field with 12 pumpkins in it. Both fields have a combined total of 107 pumpkins. If the farmer doubled the number of pumpkins in each row of the large field, how many pumpkins would he have? Okay, so this problem is actually a step beyond what we have been doing. This is a multi-step problem. I would take this and I would start drawing. So we have a field with 19 rows of pumpkins. Imagine 19 rows of these things. Plus a small side field with 12 pumpkins in it. It says both fields have a combined total of 107. So if I would add these two fields together, I get 107 pumpkins. Now, right now, do we know how many pumpkins are in each row? Like, I know there's 19 rows and I know there's 12. Like, do you know how many pumpkins are in this field or how many pumpkins are in each row? Well, probably with a little bit of math you can. A little bit of solving equations, we can figure this out. The problem goes on to say if the farmer doubled the number of pumpkins in each row of the large field, how many pumpkins would he have? So we actually need to find this number in order to do the problem. We want to double how many pumpkins are in each row. So let's solve this problem. I'm going to write myself a little equation. I'm going to say 19p plus 12 equals 107. So what I'm doing is I know to find the area of a rectangle, you take length times width. To find how many pumpkins there are in each row, you take the number of rows times by how many pumpkins are in each row. And that would give me how many pumpkins are in this field. So 19p is how many pumpkins are in the large field. Plus 12 pumpkins in the small field gives me a total of 107. If I solve this equation by subtracting 12 on both sides, 19p equals 107 minus 12 is 95. And then I'm going to divide by 19 on both sides. And p equals, divide by 19, 5. So I know that p is 5. Now, stop and think for a second. What did we find? We did not find the solution to the problem. This is not the answer to the equation, or to the whole problem. We found how many pumpkins are in each row. I know this piece of my pretty picture is now 5. There's 5 pumpkins in each row. But this is not the solution to the equation, or the whole problem, I should say. The problem says if the farmer doubled the number of pumpkins in each row of the large field, how many pumpkins would he have? Well, if you doubled the number of pumpkins in each row, you would now have 10 in each row. Still with 19 rows, still with 12 pumpkins on the side, but now it wouldn't be 107 pumpkins. How many pumpkins would he have? I don't know. That's why we have a variable. So if we do the math, if I can zoom in, there we go. So 10 times by 19 plus 12 equals x. I turned my picture problem into an equation. So this is 190, that's 10 times 19, plus 12 is x. I combine the 190 and 12, and I get 202 equals x. So instead of having 107 pumpkins that he had originally, if he doubled the number of pumpkins in each row, he would now have 202. So that was an even harder problem than normal. That was a multi-step problem. You had to do part of the problem, you get an answer, you have to use that answer to do some more math, and that's hard. And we're going to have a lot of practice of that throughout the lessons. Okay, so if you struggled through that problem, maybe rewind the video to the beginning of the problem and listen to it a second time. Now that you know the solution, you know how it's going to work out, see if you can make sense of the steps we did along the way. But if you're good, let's move on. I have a problem for you. Letter C. It says Nathan is a stamp collector. For 9 weeks, he bought stamps. If we add those to his collection of 45 stamps, he now has a total of 252. How many stamps did he buy each week on average? I'd like you to try this problem. So pause the video, do the problem on your own. When you're ready to continue, hit play, and we'll go through it together. All right, so let's see how you did. 9 weeks he bought stamps. So 9 weeks he bought stamps. If we add those to his collection of 45 stamps, he already has 45, he now has a total of 252. That is the equation that I'm going to use to solve this. This is a multiplication. So for the 9 weeks he bought stamps, that's a multiplication. It's the number of stamps he bought each week times by 9. And if he bought a different number of stamps each week, that's why it says, well, how many stamps did he buy each week on average? I'm going to solve the equation. I'm going to get rid of my addition and subtraction first by subtracting 45 on both sides. 9w equals, I don't know, 252. 252 minus 45 is 207. When I divide by 9 on both sides, w equals 207 divided by 9, 23. So each week on average, he bought 23 more stamps. It's good to label your answer. I have a bad habit of not labeling my answer, especially for word problems. I'll try to do better. Now we could check our solution. If we plugged in 23 back in for W, 9 times 23 plus 45, we should get 252, and we did. So I know that 23 is the solution. Letter D. This is kind of an interesting little problem. It says, what is the length of each side of the triangle if the perimeter is 36? I actually would like you to see if you can try this one. So pause the video. We're going to go through it, but pause the video and try this. See what you can do. And then when you're ready to continue, hit play, and let's go through it together. So hopefully you remembered that perimeter is what you get if you add all the sides together for any shape. It doesn't have to be a triangle. So if you add the sides together of any shape, you get the perimeter. So if I take this triangle, and I'm going to take 10 plus the 3x plus 5 plus the x plus 1. I'm going to label each side. There's 10 plus 3x plus 5, that's this side, plus x plus 1, that's this side. So I'm adding all three sides together, and it says the perimeter should be, not 33, 36. And we want to solve this. What is the length of each side of the triangle? Okay, well, let's see. There's a lot to combine on the left side of this problem. I have a 3x and an x that can be combined together. 3x and x is 4x, because that is 3x and one more x. An x by itself is a 1x. I can combine my constants. I've got a 10 plus a 5 plus a 1. 10 plus 5 plus 1 is 16. And now I can continue solving this equation. So I've simplified. I made the problem easier to solve. Now we should look at this and go, oh yeah, I know how to do this. I'm going to get rid of that plus 16 by subtracting it on both sides. 4x equals 20. I'm going to divide by 4 on both sides. And I know that x equals 5. I hope you didn't stop there, though. X equals 5 is not the answer to this problem. If you stop there, I want you to go back and look at the problem again. Read the question. What does it say? What is the length of each side of this triangle? X equals 5 is not the length of each side of the triangle. So the answer to this problem is maybe a sentence or a list. The length of each side of the triangle. So I have a length of 10. A length of, if I plug in 5 for x, 5 plus 1 is 6. If I plug in 5 for x, 3 times 5 is 15, plus 5 is 20. Those are the three lengths of this triangle. So again, once you get an answer, make sure that your answer makes sense. Make sure you answer the question. And that's it. Summary. In your own words, describe how you would solve this equation. So use actual words. So first you do what? And you get what as a solution. Then you do what? Finally you do what? Okay? Take a minute, pause the video, write out your words, think about it, each individual step. When you're ready, continue, hit play, and we'll go through it together. All right. So first you subtract 3 on both sides. And you would get 4x equals 12. That's what you would get after you've subtracted 3 on both sides. Then you divide by 4 on both sides, and you get x equals 3. Finally, there's nothing else to do. So we don't really need a finally u. And you get a solution of x equals 3. So that's the steps you would go through to solve that problem. Thank you for joining me for this lesson. Toodles.